Okay, in this video, we are going to learn how to use Excel to find percentiles. A percentile is a score for which a given percentage of the data is less than or below it. So we say that the xth percentile, p sub x, or in Excel, if I don't want a subscript, I'll just write it px, is the score for which x% of the values are less than or below it. Now notice if I just write px, I know it's not a probability because it doesn't say p of x, right? So px means percentile, p parentheses x means the probability of x. Now percentiles, though, do involve probabilities, as we'll see in a moment, because to find px, we're going to use the norm.inv command, where x% of the data here is referred to as the probability in the norminv function. We also need to tell it the mean and standard deviation for the distribution we want to find this percentile for. The first problem here says find the first quartile P25. Well, I've just been talking about percentiles. We see that P25 is the 25th percentile. It is also referred to as the first quartile because 25% is 1/4 of the data. So P25 is the first quartile Q1, also referred to as the lower quartile. The second quartile, which is the 50th percentile P50, has 50% of the data below it, so it could be called Q2, but it's usually simply referred to as the median because half of the data is below it. The third quartile has 75% or 3/4 of the data below it, so that is Q3, and this is also referred to as the upper quartile. All right, so let's go ahead and find these. So we use the norm.inv, where inv stands for inverse. It's called an inverse because now instead of entering a score and getting a probability, we are doing the opposite or the inverse of that. We are entering a probability, which is the percentage part of the percentile. And then we have to tell it the mean and the standard deviation for the distribution we are working with. And it will give us a score. So it's an inverse function because we're giving it a probability and finding it a score, rather than the norm_dist function where we would give it a score and then find the probability. So here we see that 67.11 inches is the height for which 25% of men's heights are below it. The median is exactly in the middle. It's the 50th percentile. And if we look back over at our graph here, when you're right in the middle on a perfectly symmetric distribution, so that you have half of your values to the left and the other half of your values to the right, then that's your median. But when it's perfectly symmetric, we can see it is also the mean. So the 50th percentile, P50, which is also the second quartile, Q2, which is more commonly referred to as the median, is the same thing as the mean when you're working with a symmetric distribution. So here, when we want to find this median, we can do it with the norm_inv command, where we put 50% here, then the mean and standard deviation. But we see we simply get back the mean of 69. Let's now find the third quartile, or the 75th percentile, using norm.inv, And so this here has 75% of the data below it with the mean of 69 and a standard deviation of 2.8, and we get 70.89 inches. Let's look at some other types or just other examples of percentiles. So here we have the 90th percentile, so NORM.INV, and you could actually put 90% if you didn't feel like writing it as a decimal. Just wanted to show you that. We still have the same mean and standard deviation we've been using, and there we get 72.59 inches. And if we want to find the 10th percentile, like I showed you with the 90th, you could enter 10% instead of the decimal, actually put the percent symbol. Mean of 69, standard deviation of 2.8, and here we have a height of 65.41 inches. Now, not all questions that require a percentile computation will actually say the words percentile, quartile, or have P25 or Q3 or Q1. We might see them, as we do in numbers 12 and 13 here, as different kinds of questions. What height separates the shortest 2.5% of men from the others? So notice we're separating the bottom 2.5%, so this would be the same thing as P22.5. This one, what height separates the tallest 2.5% of men? This now, the 2.5% tallest is in the right tail. It's separating the bottom 97.5% from the tallest 2.5%, which actually the 97.5 percentile. Let me show you that with the picture here. So when we see the bottom 2.5% would be down here, so in this left tail, we would have 2.5% of the data, which then corresponds to the percentile 2.5. But if we were separating the top 2.5% from the rest, the top 2.5% are up here in the right tail. So now it's in the tail we have 2.5%, which means then that 97.5% are below this. So we actually have 97.5% below this score, which means we are finding the 97.5 percentile, or P97.5. I think the drawing makes it much easier to understand. So let's now go back and find these percentiles. So norm.inv, 2.5%, comma, from our distribution has a mean of 69 and a standard deviation of 2.8. So we have 63.5 inches separates the shortest 2.5% of men. And now if we want to separate the tallest 2.5% of men from the shortest 97.5% of men, we can do 97.5%, comma, 69 for the mean, 2.8 for the standard deviation, and we have 74.5 inches is the height that separates the top 2.5% from the rest. So I hope this video was useful in showing you how to find percentiles, how they're related to quartiles, and a little bit of how it all matches up with the normal distribution graph. Thanks for watching.